So hello everybody, my name is Jamie Harrell. I'm the Business Intelligence and Data Analytics Lead at Emory Goizueta Business School. There's been a couple of questions. No, I don't teach. No, I'm not a faculty member, I'm staff. I work on the data analytics of the operations of the business, how to run the business school. And so all the statistics all the way around from teaching to finance to student success dashboards so that the and the leadership can make data decisions how to run the business. I could walk around with, but I'm stuck at the button every now and then. You wouldn't see or wouldn't be able to enjoy. I'm good, thank you. So the first thing I want to talk about is the use of the words data-driven versus data-informed. You will hopefully never hear me say data-driven, and you probably do hear that term a lot in the industry because data-driven typically can raise a lot of anxiety in people because they're thinking that the data is making decisions for them. But more importantly, data-driven decision-making tends to bring in biases and amplify those biases. Because if you're just looking at the data and the data is created by people and people have biases, then that data is going to inherit that. And if we're making decisions that are strictly data-driven, we're going to be making biased decisions. So what we want to talk about is data-informed decision-making. Because we can look at the data and we can say, it seems to say this. But I know that there's some influence in there that we don't want to import into our decision-making. And so we're going to make data-informed decisions, not data-driven decisions. There's a great example of this at Emory. And a colleague of mine likes to talk about the Ebola room at Emory. Does anybody remember the Ebola crisis a couple of years back? The Ebola room at Emory was there empty for almost, I think, 10 years, costing millions of dollars every year. And if you were making a data-driven decision about the Ebola room at Emory, you probably would have closed it 3 or 4 or 5 years before it was needed. That would have been a data-driven decision. But a data-informed decision says, we know that this is costing us a lot of money, but we also know that something is going to happen somewhere in the world and we're going to be needed. And it worked. So that's the difference between data-driven versus a data-informed decision. So hopefully change that language when we're talking about making decisions and doing decision analytics. So looking at how we actually use data analytics in business, there's a maturity model of kind of where we start, what's the easiest, and how we go towards being able to get the most insight out of our data. The hindsight, what has happened, we talk about as descriptive analytics. We look at all of the data of the business, we pull it into a database, and we look at it and say, this is what happened. And that's really usually the entry point. You're talking about stock reports, you're talking about financial reports. But when we really want to talk about insight, we move towards this diagnostic analytics. And we're talking about why did it happen? And it's visualization drill downs for this. So we can see something that happened, and now we want to understand why. And so we dig into that. And that's really what we're talking about today. And what we're going to do is we're going to show some visualizations, and then you can begin to talk about why those changes happened. Oops, excuse me. Now, foresight, when we talk about predictive analytics, this is really, really fun stuff. I'm not talking about this today, but this is the part of my job that I love. I get to do regression analyses, and I get to do case analysis and sensitivity analysis. Say, if we were to do this, what would that change? It's a lot of fun. It's a great topic. You get more into the data science side than the business intelligence side when you're talking about that predictive analytics, and it's really, really cool stuff. And then in the future, we're talking about prescriptive analytics. And this is where things get really kind of tricky because we don't want to bring in those data-driven decisions here. And this is what this is kind of talking about. It's letting machines make decisions. And that gets really scary. There's a lot of ethical things that we need to talk about when we get into that area. But it's actually a pretty cool field. We're going to talk today about Microsoft's business intelligence platform. And that's what we use at Emory Goizueta Business School, and it actually, according to Gartner, is the most, is in the Magic Quadrant and has the most completeness of vision and ability to execute. So it's a very, very nice set of utilities and packages that you can use. A lot of this you can use for free as a developer as well. When we talk about Microsoft's business intelligence platform, we're talking about SSIS, SQL Server Integration Service. This helps you get data into SQL. You have a big data set, whether it's a CSV or whether it's from SPSS, some statistical package. We want to get that into SQL Server so that we can do some work in it. We're going to use SSIS for that. I'm going to show a little bit of this today. SSRS is the SQL Server Reporting Service. So this is going to be for your stock reports. If you're running reports, you'll probably generate those with descriptive analytics side. We're not going to really showcase that today, but it's a very useful tool for helping understand what happened. SQL Server Analytics, SSAS, is Microsoft's answer to creating OLAP cubes. OLAP cubes are three-dimensional databases where you can actually do data exploration onto, if you want to look at your sales by region and by product line, it'll help you create calculations around that so you can see what's going on. SSAS is a tool. Again, we're not looking at this today because you tend to look at these things inside of spreadsheets and pivot tables and drill down. We're going to go a little bit further than that into the visualization side. And PowerBI, this is what we really want to talk about today, which is data visualizations, data dashboards, and exploration. And this gets us into a little bit of that exploratory, what happened and why. At Goizueta, I just wanted to show you this because there is tons of different technologies that we use. You're looking over here at the Power BI side, but we do a lot of work from flat files, from source relational database systems, from cloud data. We pull that all together using Microsoft Flow and using Halo, which is a wrapper around the SQL Server integration services. So it's all Microsoft-based technologies for the most part. We'll use RStudio when we're doing some predictive analytics, and we'll use SAS cubes when we want to look at things from 3 or 4 different dimensions. We'll take all that data and we'll bring it into Power BI, and that's what we're going to look at today. So just wanted to give you an overview. If you download these slides and you want to see, what we're doing, it's just doing visualization, how we get it there. These are the technologies that we're using, and I think it's a lot of fun. It's pretty cool stuff. The thing to keep in mind, and a lot of data scientists get in trouble here, is that data analytics and data visualization is software. And if you treat it like software, it'll be repeatable. If you treat it like experimental and you're just running a couple of quick analyses, then you'll have a very difficult time repeating that and making answers next time. Dev, a test in a production environment. We use all of the same tools, for example, Git for revision control, that bug tracking systems. You want to treat this like software so it's a repeatable process, so that next week when the data load runs, you're going to get the same answers as you did the last week. So at Goizueta, we talked with a couple of our friendly competitors, which is really interesting when I come from a commercial market where you would never give away your trade secrets, right? But in higher ed, it's really kind of interesting. We'll talk to each other and say, hey, this is how we did it. This is what you could do, and they'll actually share code with one another. It's pretty interesting. So we looked at what other groups were doing. Clemson with the visualization, where they're actually analyzing what's going on. And so you can actually get some really good this of need to move up in salary rather than looking at a big chart. It really, really helps. Another group at Stetson was looking at their programs. They partnered with Equifax to get some data, their graduates. And students were earning when they earning out and how much they were earning 15. Extra data connected to, and we can see the MBA program. You really can't see this in these slides, but if you download them, you can see it, where MBA program, they were coming in at a certain level, and 5 years out, they're earning, $50,000 or $80,000 more than their incoming salary. It's a really good visualization and way to show the value proposition of that particular degree. So I just wanted to show you a couple of examples of what we're doing at Goizueta and what we learned from our peers when we were trying to figure out how we're going to do data visualization at Goizueta. There were a couple of key learnings. Now, one is to work with a team of 3. I know that's not always possible if you're with a small company, and sometimes you're going to need to be all 3 of these. You really need to work with a data analysis expert, because this is a person who knows how to manipulate data, to pull it into the database, to clean it up, to manipulate it, to actually up perhaps some that you can visualize ways. Then you're going to want to work with a data visualization expert. Maybe that's going to be you, maybe it already is you, and that's why you're here, to come learn Power BI, to become this visualization expert. And then you need a subject matter expert. This is really important when you start about creating analyses that will make decisions. Because if you don't know the data, and I fall into this trap as well, I don't know the business process of admissions at Goizueta Business School. For example, if I were to come to one of the business leaders and say, here's what the data says we need to do from an admissions perspective, I'm going to make the completely wrong decision or the completely wrong recommendation. So you need a subject matter expert to look at this data with you. And that helps round out your team of 3. Sometimes it's all one person, but you really should be working with a team of 3 when you're doing visualizations at a business. So I wanted to show you a couple of quick Power BI dashboards. These are live, or pictures of live dashboards from Goizueta that we've done. And what we're seeing here, this is really hard to see for you guys, but I wanted to just call it out. On the left-hand side, there's this trend where the black data set is decreasing, and the red data set is increasing. What is this? Since about 2016, we're seeing an increase in MBA students utilizing federal loans to get their MBA. Students are less willing to take out big debt to get their MBA. At the same time, we're seeing a significant, this is over here in B, where the black group is growing and the red group is decreasing. We're seeing an increase in scholarship funding, the number of scholarships that we're giving to students that's being funded out of operations budget, not being funded by a foundation. It's coming out of our operations budget. And so there's a swing here of several $1 million from 2016 to 2018. It was coming from federal student loans. Now it's coming out of pocket, out of the business. And that hits the bottom line. And so you look at this and you can begin to ask the question, is this happening to us or are we happening to it? Are these decisions that we're making intentionally, or should we be making different decisions about our admissions process or our scholarship process? We saw something really interesting. This shows the enrollment of one of our programs, which is our 1-year MBA program, grouped into, or by age group. And so what we're looking at here in the highlighted area is that since about 2016, there's a decrease in the number of students that are 23 to 30 years old that are entering our 1-year MBA program. At about the same time, we're seeing more students that are 30 to 40 years old going into that program. And what does that mean? I'm not an admissions person, so I don't know. But I asked the question, is this intentional or is this a market shift? And we wouldn't know this without the visualization. You'd have to dig into the raw data and you probably wouldn't see that trend. I don't know what the answer is. It really doesn't matter. We let other people make those decisions, but that's what our subject matter expert is for. So let's build a dashboard. I'm going to get a little bit interactive with my computer here. And don't worry about taking notes. If you want to take some pictures, that's great. At the end of the presentation, a GitHub address that you can log into. You can download you can't download the data set because it's too big until I figure out large file support on Git. But you can download the Power BI file. You can download, I think, there's even instructions on how we got to some of these visualizations. Now, I wanted to pick an interesting data set. And the one that I picked was from Harvard's Implicit Bias project. Who knows Harvard's Implicit Bias? This is a really, really cool project. Let's see if we can actually get to it online. Well, sugar. Basically, it's not showing that screen. Let me see if I go here. Sorry, didn't do my tech check. No, it's not giving me the screen. Okay, unfortunately, I can't show that. But basically, what they do is they have tests that you are given a phrase or a statement, and you either agree or disagree with it. And how quickly you agree with that or disagree with that statement helps indicate what your implicit biases are. They've got some great ones. This one is about gender and science. So a positive correlation with gender and science in this test, something bigger than 0, indicates that there is an implicit bias that men are more likely to be engaged in science ventures, right? And that if there's a negative correlation, it's about women being engaged in the arts. Or leave as what your bias is towards who is in the arts versus who is in science. So it's a really fun data set to play with. The short answer is pretty much everyone says that men and science are related and women and arts are related. And we'll see some cool trends about this. So it's not just Power BI because we've got this gigantic data set. And so again, you can download this and you'll be able to see what all of these are. But there's about 7 different packages, software packages that it takes to get to this visualization. How are we doing on time? Perfect. Okay, I'm going fast enough. PSPP is an open source version of SPSS. SPSS is IBM's statistical analytics software. When we get large data sets, they tend sometimes to be in this SAV format, which is a SPSS format, proprietary format from IBM. So we have to download some open source software to open that up, convert it to CSV so we can then load it into our database. Notepad or GVim, whatever your favorite good text editor is, Notepad++ over Notepad, so that we can look at large files and inspect them and see what they look like to make sure that we're going to load them in correctly. We're going to use SQL Server Developer Edition, so you can install this on your machine for free. We're going to use SQL Server Management Studio so we can write SQL queries and create databases. We're going to use Visual Studio Community Edition, which is free for developers. So use that to create SSIS. If you remember, SSIS is the SQL Server Integration Service, and this is a piece of software that helps you create automation for importing data into SQL Server. And then we'll use Power BI, and you can actually download Power BI for free, 60-day free trial of Power BI. And I believe you can use it on your desktop for free perpetually, but if you want to share visualizations, they're very cool. You can share them out to mobile. You can share them within your work group. Then you have to have a commercial license of it. Interestingly, to get Power BI, you have to have a commercial email address. A Gmail address isn't going to work, so make sure you use it from your business. So the first thing we do when we get this big data set, and it's really big, it's so big I can't upload it into Get, is we have to prepare the data. And we call this ETL, extract, transform, and load. We're extracting it from something, we're transforming it, we're changing it into a way that the visualizations make sense, and then we're loading it into SQL Server or into Power BI. So the very first thing is we have to convert this SPSS file to CSV. It's a kind of a pain in the butt if you've never done it. You got to do a lot of Googling and find it, but I've put a couple instructions for you on how to do that. We're going to skip over actually doing this. I'm just calling it out so that you know you can't just automatically pull something into Power BI if it's in this format. If you have an Excel spreadsheet, if you have something that's already in a database, if you have something that is a CSV already, then you can load that directly. But this particular data set is very, very big. So the first thing we want to do when we get a new data set is explore it. Because if you just throw it into your visualization tool, you're not going to know what's going on. And so we look at it. I wish we could see this a lot better. But this is our CSV file with a header row. Notice it is comma delimited. Some of the data is quotes around it, so it is quote enclosed for the data elements. It's looking pretty clean. There's empty spots with a bunch of commas together, which means that the fields are lined up, the commas, so we're not compressed. So we can actually load this fairly easily because it's a good clean data set. We can look at it with Excel. But what happens when we do? File not loaded completely. So remember when you're using big data sets, particularly CSV data sets, when you load them in via Excel, strange things happen. Excel will change your dates to an internal date format number. If you've loaded this in Excel, never save it in Excel because you're going to run into issues because it likes to change things up. The file is too big for Excel. You're going to lose data if you. It's got a good header line. The data is quote enclosed. The values are output, not just numerics. One of the parts of the SPSS command was to convert the fields from just numerics into their actual data values. So enumerations. 1 might mean yes and 2 might mean no. We converted that to say yes and no in the data set. So with visualization, we can see yes and no for the most part. Some of the fields don't convert, but most of them did. And what we see is there are 1,664,706 data rows in this. And we've looked at this with a text file so we can then, once we load the server, say, did we get all of it? So we want to explore it first. Now we are going to use Excel because we want to grab that first row, which is the header row that tells us what fields are there. We're going to use that to create a create table statement in SQL. So we're going to copy that first row. We're going to paste transpose it so it's all in one column. And then we're going to use just a simple function. Again, this spreadsheet is on the GitHub so that you can look at it. It's just a command that says concat so that we can put commas in there and we can put the data field type. They're all varchar 255s, but we can create a create table statement out of this rather than having to write the whole thing by hand. Now we get to the work. SQL Server integration service. We're going to create an SSIS package with Visual Studio. I wish we could see this better, but SSIS has 2 types of control elements. One is a control flow task, and this is like a program. Start here, go to the next step. Sometimes you can loop, and these are created with visual representation of what's next in the line, okay? Then it also has a data flow task, which is what we use to move data from one location into another. What we're going to do on the control flow side is we're going to truncate the table that we've created to make sure it's empty, and then we're going to load the CSV into that table, and that'll give us the raw data in SQL Server. On the data flow task, we're going to read from that source file. We're going to write it to a destination. We're going to map the columns from the source to the destination, and that source is the CSV file, and the destination is the SQL Server. When we execute this package, it's actually going to take that entire CSV file and load it into SQL Server. After we load the raw data, we need to clean it because your raw data is coming in as text character data. A lot of the things that we want to measure are numerics, right? We want to know what your implicit bias score was, and that's going to be from 0 to 1, and that's a numeric. And if we look at that in a visualization perspective as just a text string, we're not going to be able to do math on it because we want to calculate the averages over an entire group. And so we're going to do a cleaning step, and this is going to have a control flow task. This package is in the repository, so you can download it and you can take a look at it and see how we created it. This is the data flow task side of it, where we've got some error handling in here, because remember, this is a program, we do error handling, and we dump our error rows out into an error table, and then we dump our clean rows down into a clean table. So at this point, we now have a clean table, after we execute this, that has all of our data set up how we need it with some of its character data, because those are our categories, and we have numeric data that describes what that particular test element, what your implicit bias was when you took that test. Now the fun part, we're going to create the visualizations. So that was all just to get to the point where we can use Power BI. When you open Power BI, I'm going to really have to figure out how to show my screen that's not the presentation side because I want to show you some live parts of this. You want to get your data from the SQL Server. And there's an option at this point where you can choose to import the data or you can choose a live query method. If you're doing this on a data set that's going to change over time, if it's an operational data set that it's getting new records every day, you want to choose that live query method because all of your visualizations will go back to the data source and recalculate every day. If you use an import, then you're only going to have a static data set. It's good for playing and good for learning, but as time goes on and more data appears in your database, if you've imported what was there, you're only going to see that data. So if you're building operational decision-making systems, then you're going to want to use that, the live query method or the direct query method. Power BI has some data model tools where you can change fields, you can add fields. Like if you accidentally imported a string and you really wanted to do some math on that field, you can change it inside of Power BI. My recommendation, my strong recommendation to you, if you're do it in SQL Server because you can have a lot more control over what the data types are, what they look like, how many depth of precision that you have in that data. SQL Server is going to give you a lot more clean transformations. You can do it in Power BI if you need to, but you really want to do this in SQL Server. When I loaded this data set into the visualization into Power BI, there is a column that says whether or not the person who was doing this implicit bias test completed the test. And so I've filtered out, when the data loaded into Power BI, only those records of the tests that were completed. Because we want to we don't want to pay attention to some of those that haven't been completed. So let's take a quick look at some actual visualizations. So this one's a lot of fun. I highlighted Georgia over here. The color depth is telling us how much that people from that area were biased towards connecting male and science versus female and science versus male and art and female and art. The darker the color, the more likely the people are to have an implicit bias that men are better, I don't know what, at science, I suppose. And Georgia, incidentally, is pretty dark compared to some of the other areas, which is the world that we live in here in Atlanta. Arkansas is pretty dark over here. Interestingly, California is still pretty dark too, or at least maybe it's average with some of the mid-range areas. This visualization is showing us by gender. These are, 5 different genders of which genders more closely associate men with science. And the top gender, anyone up there have a guess? That's male. The next one down is trans male, and then female, and I don't remember, it was 6 genders, goodness. And I think trans women are down here somewhere with associating less of an implicit bias of associating men with science. And then the very top one was just the straight male-female category. But what's going on over here? This is a really strong correlation from left to right. It's almost a straight line. This is the association of men and science graphed over age. It's #1 predictor of all of the various demographics is age, which is pretty interesting, but also reflective of what we see in a lot of the research studies, is that age is the #1 predictor of acceptance of people who are either out of the gender binary, LGBT, et cetera. Age is the #1 predictor. But this gives us a very good way of seeing it. I'm going to try to get Power BI to show on my screen up here so that we can actually play. Is our tech person in the room? let's see. So bear with me a moment. And yes, that would be really helpful. Thank you. Let's hit pause on the recording, because the live visualizations are so much more fun. You can actually watch me create one. So,
Jamie?
yes.
And that last slide you showed, was it showing that older men are the ones who have the stronger correlation to associating science with?
Older people.
Just older people.
Yes. So here's the graph. All this is, the numbers range from about 0.3 to 0.6, with 0 being no correlation of or no implicit bias of male, female versus sex in the arts, or excuse me, versus science in the arts. And so around 0.3 is where most people who have the least amount of that implicit bias are, and that's this kind of plateau at the age. And as you get older, it goes up to about 0.6, which is a much stronger association of that implicit bias. So this is just age. The gender ones are over here. I believe this one is going to be education level. And it will pretty much very directly correlate to the amount of education, with the least education having the higher association. And I believe this one down here is PhD. If you have a PhD, you have a much less strong implicit bias of science and men versus science and women. So if we end this slideshow, oh goodness, why is it not giving me? Well, we're going to come up to my screen here if we don't get it live, because there's some really fun stuff that we can do with PowerBI. Hey there, I wanted to show some live, just show my desktop live, and the screen has gone blank when we do that. When I run the presentation, it shows. I appreciate your patience. Yes? So PowerBI itself is very accessible. You can load an Excel spreadsheet into it. You don't have to do all of the exercises that we went through to get the data in. It just happened that the data I was looking at was this SAV format, which is from SPSS. But you could have something in a spreadsheet loaded in, and you're making visualizations in 5 minutes. It's very accessible, very easy. There are a lot of nuances when it comes to learning how to make the visualization that you want, but it is very accessible. And it's free, yes. So, you know, Google has a data analytics site that has tons of data sets in it. I happen to pick this one because I think it's rather interesting. But yes, Google, I believe it's analytics.google.com. Yes. Okay. Kaggle, C-A-G-L-E? Kaggle.com. And you had a question or a comment?
I had a question about the study, actually. I'm not sure if I understood this correctly before, but you said that the amount of time a person responded to the statements, true or false, is also...
Yeah, so if you look up Project Implicit, they'll give you, and if you take a test, it'll help you understand how they have calculated your implicit bias. But I believe it has to do with how long it takes you to answer the question and which way you answer the question. Because if you're answering it by gut instinct, then it's going to be more of your implicit reasoning, versus if you look at a question and you think about it, you're giving your brain an amount of time to do some explicit reasoning around that, rather than just saying, what was your gut reaction? And so I believe it does have to do with the amount of time, how quickly you answer those questions, and which way you've answered them.
Does that play a part in the visualization?
So what that comes out to is a net score. So there's about, several dozen questions that you are asked, and they're asked in a specific order, and then they ask them in the other order, and then they swap the questions to ask it in the opposite way. And they're measuring how you're answering each of those questions when they're asked in different ways and at different times, and in different orders. And that ends up giving you this net score, which is between -1 to 1, where 1 is an association, a direct association of gender to science, or male gender to science. And a -1 would be the opposite, where you implicitly associate female gender with science. Turns out almost all of the data is above 0, because most people have this implicit bias of science and masculinity.
How comparable is like Power BI to say technology like Tableau?
So it's very similar. One of the slides was the Gartner Magic Quadrant that showed those in the top right quadrant are more or less the most robust and more mature technologies. Tableau was in that area. They're probably number 2 in the Gartner Magic Quadrant. So it's a very similar product. I think the biggest difference between Tableau and Power BI is cost. If you're going to install a Power BI instance, at least institutionally at Emory, it cost us $2 a month per user to run Power BI. If you're going to install Tableau, the Tableau server is probably going to cost you a couple $100,000 for the license. There's a big difference in that cost. So the accessibility, you asked, what can we use to get started? And this Power BI is a great place to get started. And it's actually one of the more mature products that are out there. Yes?
What would be the trade-offs to using like pandas instead of SQL, and like some of the Python libraries like Seaborn and Matplotlib instead of the Power BI for visualization?
So a lot of people who are using pandas, that are using Python, etc., are going to be data science people, where you're going to be doing predictive analytics, probably. You're going to be running regression models, multivariate regressions, so you can create predictive analytics. You may create case scenarios to see which one ends up better, and so that's kind of that predictive and prescriptive move. We do see R is actually embedded with Microsoft SQL Server now, so you can do some of that in SQL Server as well. But some of the trade-offs are going to be, I see a lot of data science people using Python that are using it as a tool, a method to make one-time analyses. I don't see a lot of people using it to make decision analytics systems that are continuously running, that are loaded every day with the next set of data. They tend to be kind of one-off analyses. But the trade-offs I think you're going to see most importantly from a business systems perspective is that Power BI integrates directly with Office 365, and you can publish your data visualizations to a group in Office 365 and have that, you maintain who has access control to that group. And if you're in that group, you can visualize those on your mobile apps. You can visualize them on your desktop. It's really connected to the enterprise versus something like a standalone tool where you can make one-off visualizations. You're going to have to copy and paste those into a PowerPoint, for example, to get those to management, right? No, please do.
A huge difference between like this work and like the data science?
There is. There is. When we talk about business intelligence and data analytics, the data analytics adds a bit of the data science to it, but I am not a pure data scientist. My experience and my background, if you're going to do data visualization, and is going to be a lot closer to a software developer background, where you're using SQL Server, you're using programs to load data in. versus using Python, using R, using Hadoop and whatnot. That's more of the data science side, and there's degrees for that, right? You can get the Master of Science in Business Analytics at Goizueta Business School, for example, and that's good. 5 minutes. That's going to be a data science focus versus if you were in the MBA program at the business school, you're going to get more of the business analytics, decision support systems. So yeah, they're two different fields. A lot of recruiters who aren't well versed in the language will try to fit a data analytics or a data visualization person into a data science position, and it's not going to work. You're not going to get that job. It's just going to be a waste of time. So definitely pay attention to the two sides of data. And this is so disappointing. I'm so sorry that we didn't get to do the tech check and actually show my desktop. It was a bit earlier today, though. More questions? So yes. Oh, I know, thank you.
But I'm curious, I may have missed it at the very beginning, but how did you find that passion in this very specific field is what you just thrive on?
So I think it's my background. My degree is in computer engineering, my undergrad degree from Georgia Tech, so I've always been a programmer. And yet I got into business early in my career and did a couple of startups, and so I really wanted to understand the business aspects of data and tech and science, like what makes good products, what makes them sell. And so I got into the business side of it and I did my MBA. And so I think that combination of the MBA plus the science side of it were really a driving factor in me finding data and being able to make data-informed business decisions from those data sets. So I'm lucky, I guess. I don't know.
So,
Yes?
and so you got into it with businesses, this applicable, I guess, outside of business and in other areas where there's a lot of data, but nobody really knows what's going on?
Data visualization, the way that I like to think about it, it takes this kind of very nebulous, kind of mess that's out there, and it puts a picture, builds a picture with it. And from that picture, you can see trends. And so any data set, it doesn't matter if it's a business data set or an implicit bias data set, you can build those pictures, and it really creates information out of that data. And that information is what helps you inform your decision-making process. So yes, no matter what field you're in, there's data. And it's out there, and it's a matter of acquiring it, making sure that you have the system set up to acquire that data so that you can make decisions from it. And we're all, probably most of us are in tech. If we're building websites, right, some of that data might be Google Analytics, or it might be triggers that you have set up, tracking pixels. We're not going to be able to get it. Okay, well, we're out of time here anyway, but anyone that wants to look at some of these visualizations, I so much wanted to show you how to build them. But if you want to look at them, come on up and you can take a look at my computer and I'll do a quick walkthrough of a couple of visualizations. Thank you. I'm so sorry.